Hi there, so in this video we'll talk about post-processing using Ensight. So far we have seen the post-processing in Fluent. It works really well, okay, but sometimes you can do this animation, so it's not very flexible to do it in Fluent. So I like to use Ensight. It's a program that comes with your installation of ansys. So if you didn't run the case, here you're going to have the Ensight output of this case that I'm using for 2%. Now, all to illustrate this case of the cylinder. So, well, let me show you again how to save that Ensight format. So first, see that in Fluent we have all these options. We can do the post-processing nicely. We have visit here that you have the option to create animations and everything. But however, if you want to save all the outputs of Fluent, for instance, you start to use here save every given time step and save all and keep all the solutions. Doing this post-processing, these animations, is not very straightforward in Fluent, so it's better to use another external tool. So Fluent comes with ansys comes with Ensight. Okay, so see here that in this case I created this automatic export function. So this one, what it's doing, so for instance, you go here, I already have one, but let me show you another one. So before running this simulation, so this works for steady and unsteady, okay? So I'm showing this case for steady, but you can use it also for steady. You choose the format. So see that here you have many formats, so probably some of you will be familiar with stack plot. You can also use stack plot, field view, or any of these formats. So in this case, I really like this one. It's a very compact format, so you just select this one, the location binary file, and what you want to save. So also these files tends to be lighter than the Fluent files. Now the Fluent files will save all this information. Okay, so for instance, you want to export only this and velocity, just select that one, give a location where you want to save it. So usually I like to save it in my current directory. So you go like this and give it a name. So put it like this, and then you give export data every, so you can give time step, so you can say export every 10, 100 time steps, it's up to you. So you put one time step will be every single iteration, so that at the end you will get a very large file, so a lot of information. So but it's up to you. Or you can also give float time, so I want to export every 0.5 seconds. Okay, so it's up to you. I also recommend you here to deselect this one, so you get a single file. If you leave this one, you will get for each time step, for each solution, you get a different set of files. So you're going to get a lot of files. They are not smaller or larger, but more files. So in the end, for instance, in this case, I have, so see that I have a single set of files. Let me open here, and this single set of files, I gave this name, and I save here all the fields. So then inside you can open the file with the extension .ncast, and that's all. Okay, so you can do it like this. So this will do it while running. Okay, it's up to you to choose the saving frequency, or you can do it after running the simulation for the given solution. So for instance, see here that I have the final time step in time 100. So you go here in File, Export Solution, and do the same. Select here and then select the fields. Okay, choose this data and write. So I will call it here X test. And remember, here you're saving in this way. You're saving one single time step in the way that you put it here. Calculation activities every given time step that you set up there. So as you go here, see that you will have here the file. Okay, and now you can just open the .ncast file inside. So now let me show you, so now that I clarified this one, how to save this one. So honestly, I like to do these animations when I want to do the animation. So recall that in the presentation, in the case presentation, let me go back to that case presentation here. So in the case presentation, all these movies that you see here, they were created using Ensight. So all the data that you choose, the data that you want to save, and then just post-process it and do the movies, okay? So that's all. And even these plots, you can do it there with no problem. I'm not going to address those are in advance, so just let me show you the basic stuff. So now that I open here Ensight, so you will have an Ensight in your installations. You go here, see that you will have it somewhere here Ensight. You can open the file. Okay, so in my case, I will go and I have the solution here, select the encast. And this is it. So in this case, I'm loading the mesh, the 3D mesh. Okay, so see that, but it works the same for the 2D mesh, what will be just a single surface. Okay, so here you can choose orientation. So you right click here in your canvas, you have more options. So I'm not going into details, just leave it to you to play around. But what is important here in parts, you can select what you want to see. So for instance, select everything and you hide everything. If you want to see a specific patch, for instance, the cylinder, I selected the cylinder there, you see that surface. And now as you select the surface, you can select here and you can select what you want to visualize. So here you access the field that you save in your solution. So if you want to visualize pressure, this is your pressure field. If you want to visualize, for instance, y plus value, here you have the y plus value, and here you have the scales. Okay, so for instance, you right click here and see that you have more options. So I want to put it in top, I want to use this format, and then you can edit here, press edit, and you can change now the name, text size, it's up to you. Okay, then also you can click again here, select here, and also you can increase edit palette and see that you can choose different colors. Okay, you have more options, you can play with those options. But usually what I do here, I increase the number of markers or levels. So I put 11 levels, and you can choose the range. So if you choose here the range, now you are fixing the scale. So if you're going to animate this one, now your animation is fixed. Okay, so here you have some other options. So see that, for instance, now I save the solution in time. So see that you press play, the scale is fixed. Okay, recall in Fluent that scale was not fixed. Okay, but you can fix it as well, but you will do something similar to what I did here in Fluent. You access the color bars and fix your scales. Okay, so for instance, visualizing y plus year and time. So if you want to add the time marker or annotation time, see here the ellipses, you click there and see display settings, display time, and now you add time there. Again, right click here and you access on options. You can change the text size, whatever, is up to you. So we know that we have, for instance, these are the walls, the symmetric walls. So see that you can visualize that. So again, you can select what you want to visualize there. So if you want velocity, put it there and you get the second scale. But let's say that I don't want to visualize this wall surface. I want to create, because this is a 3D domain. You see there, this is your domain. I want to create a cut plane. You go here and create a cut plane. I want it normal to this one. It will be in the mid. You put it there and that's it. And you can add as many cut planes as you like. Okay, so you want to add another cut plane, just put it there. Okay, and you can cut also surfaces. It's up to you, okay, what you want to do. So let me hide this one, and now in this cut plane I can visualize, for instance, velocity. Okay, so you have the scale there, so now you can play with the scales also. The position is up to you. Okay, so let me put it here left, and I can click here and can reduce the size. Okay, so it's very flexible. Okay, you see that you have much flexibility than in Fluent in the post-processing, which is good, but it's not as robust as this one. This is a tool just dedicated to do advanced post-processing. And as you can guess, you do advanced post-processing, you have access to a calculator. So for instance, starting from all these fields that you have, all the information, you can compute more stuff. So for instance, let's say that I want to compute in this cut plane. See here that you have a calculator. You have all these operations, so you can compute gradients, you can do average, minimum, maximum values, integrals. Okay, so you have all these operations here. So let's say that I want to compute vorticity. So see here that you have vorticity. Vorticity will ask you for the velocity, access velocity there, evaluate in the pair, and now you compute vorticity. You gave it this name, and now you can access that. Okay. Here you have vorticity, it's a vector. I want to see this. Let me change the scales. -5 to 5. And voila, you have the vorticity, okay? So just choose where you want to apply that operation and compute it. So here you have many operations, okay? You have derivative, divergence, Q criterion to visualize vortices. Okay, so just surf here. Okay, so it's very powerful. You can compute mass flows, you can compute the forces. So recalling in this plot that I have here, you have this is the sampling velocity, but here you have the forces. So in this case, I just computed the pressure forces, but you can also compute the viscous forces. So it's very complete. Okay. So something, what else you can do? So for instance, in this cut plane, you can plot the vectors. So see here that you have vectors. And like in Fluent, be careful that if you have a lot of cells here, it will put a lot of vectors and it will be a little slower. So this is much faster, more robust than Fluent, but also it's a good idea that here always control the density, okay, reduce. And then you have options here just to control the scale size or how you want it, fix. And then after you create these vectors, you can just color them by any variable. So velocity, magnitude, hide this clip plane, and this is an animation and you can see your vectors there. So let me see what else we can do. Okay, so also isosurfaces. So if you recall that in Fluent we did it, here you also can do it. Okay, so you need to select your volume and here you have the operator isosurfaces. Then you choose the variable that you want to use. So see here that in this case I will use the Q criterion that I was computing Fluent, but you can compute it also inside Ensight. Select this one, you give a value. So remember, this will be the surfaces that has the same value. So I will choose, like, for instance, let me choose 10, okay? And see that there you have those isosurfaces with the same value. So let me reduce. So this one, the Q criterion is really good to tell you where you have the vertical structures, okay? By the way, you can use Q criterion just when you have the source dimension, okay? In 2D, you will see the surfaces, okay? But it works well using the vorticity, okay? Then that you have these isosurfaces, again, you can color by different colors, it's up to you, and you can animate everything. Okay, so you have many operations. What I show you here are the most basic one, the ones that I use the most time. You have click, plane, the isosurface, then vectors, create the cut planes. So just to add something additional, you can do also here, see here that you have lines, points. So for instance, you can create here a point. Let me hide everything that we don't see it. See this point there. And then I can say sample whatever velocity in this point. Okay, so see that here you will have this function query, select query, and you say what you want to do. So I want to do here, you select at XYZ over time. Get cursor, this is the cursor position, or you can give it manually here. So let's say that I want to sample here. Okay, it's telling you that you need, and I want to sample this velocity. Okay. Then number of samples, okay, and you're ready to go. So you press create and see that you sample in that location. This is okay. In this case, the location will be this point. Okay, so see that here you have again the query, and as you press down, you have the animation there, and you can control everything. Okay, so you can create queries in points, in lines. So see that you create the line here, so you can say sample along this line. It's very powerful. Okay, so at this point, I show you the basic stuff. Okay, then it will be up to you, to play more. But for instance, also something that I didn't show you. Let me go back here to the calculator and then let me see. So remember that here you have the basic operations that already exist in Ensight, but you can create more complicated operations. So see that you have here predefined functions and then the user-defined functions here. Okay, you can build your own function. So here you have the calculator. You can access all variables and all these operations you have here. Okay, so it's very complete. You can also program in Python, by the way. So to save the movie is relatively straightforward. So you have this. Okay, so whatever you choose here, then you go here in File, Export, and you can save image. You have many options. Okay, but here you have animation. Choose animation, choose your format. So probably this goes fine most of the time. Location where you want to save. So let's say that document is okay, and you call it test movie. And then here you have some options, but usually here you can control the resolution. Okay, so you can go high definition. It's up to you. And then you press OK, and it will save the movie. Okay, so I won't do it. Okay, or let me do it just to show you the beginning, and it will start to record the movie. Okay, let me cancel here. So this is the basic, a crash introduction for Ensight. Okay, so when I want to do post-processing just the last time, okay, or I have the average, the means, I can do it here, there is no problem. But then to do animations and stuff like this, I prefer to come here inside and do my animations. The final thing that I want to mention, that also you can save this state. So you see that we did many operations, we create many stuff here and new entities, and we did some operations. So you can save this one, so you need to reproduce everything from scratch. So as you go here, file, you will see here that you have save. You can save this context. Okay, so let me call it again document. I would call it test. Okay, so in this folder documents, you are going to find this context, and here you save all this state that you have here. So then when you open again Ensight, just go here, restore context, and open that file, and you're going to access this case location and then reproduce this. So that's all for Ensight. Okay, so it's a very short introduction just to show you, but most of the time what you're going to do is you're running on a steady case. You just save the solution with a given frequency, and basically what you need to do is just plot the movies, okay, the animation. So let me hide here. Okay, by the way, you can access variables, annotations, the queries, which is this. Okay, let me hide that, and let me just show the click plane, and let me hide also the annotations. I don't want to see any annotation here. You can switch on, switch off. Okay, so most of the time you are going to do stuff like this. Now play the movie, okay, and visualize this, or do the movie for this. Well, that's all. Also, well, you have a string lines, works in the same way as in Fluent. So you release string lines in your domain, and you can release it from a surface. I'm not going to show you because I'm not doing very often, but you have the option there. So again, just feel free to explore. You have many options here. Play around. Okay, just also right click here. You have many options. You can split your viewport. Okay, so you can have two different views. So that's all for Ensight. And also all for this case. As you see, simple case, but we cover a lot of material. Okay, thank you for your attention. See you next video. Bye.